this session we are going to talk about is about design and the framework. We kind of like take a break from all of the fancy technology. We in the past 1 or 2 days we talked about graphic computation, graphic database, garbage collection. Here we are going to kind of take a break. We want to talk about from the enterprise side. How we should welcome these new technologies and change. And this is a kind of a traditional topic we have covered for years about design pattern and framework. So in today's world, technology keep evolving, keep changing. So more and more voice start to come out like, do we really need design pattern? Do we really need a framework? And that's kind of the major topic we want to discuss. We didn't want to focus on technology, but actually the example we bring in today is about the technology. It's about a framework, a sample framework we build on Kubeflow to integrate data engineering and data science. So a little bit about myself. I'm the principal for engineering and data science, data engineering and data science working for CVS. But before, well, there's nothing specifically related to CVS in this presentation. And I have been working as a consultant for Deloitte for 4 years. And before that, I have been working for IBM for 12 years, worked with a lot of different clients. And now I switch my head working, representing the enterprise. That's kind of like my role. And also from my experience for the technology changing, people from time to time ask me like, do we really need to design a system that decouple from the platform? And do we really facing the situation like you migrate from one system to another system? I can share my experience like when I was working in IBM for 12 years, I experienced a major system migration once for 12 years. Well, there's many system migration, but I only experienced once. But one for the past 3 years, when working in CVS, we experienced twice. And when I work with a consulting company, and I personally worked for over 10 clients, and almost all of them are experiencing one or more major system migration. So because the new technology keep coming up, so the requirement to migrate the system kind of can become more and more frequent. So we want to focus on how the company for like the corporate get ready for this system level of change. So in today's topic, we are going to cover like this context. First is a common requirement for cloud migration and common misunderstanding pain points, and also the key to success to cloud migration. Also, we want to talk about why design pattern is one good key answer. Well, it's one of them. It's not the only one. And we also want to talk about a framework, what the key feature. And honestly, the framework and the design pattern, they always come hand in hand. Framework usually will work as a carrier of the design pattern. Also, we will have time to go through example, to go through framework we build to integrate data science, data engineering pipeline with Kubeflow. The framework is operating on Kubeflow, but it's really vendor agnostic. So the same framework could be built on top of other systems too. Now, so when we talk about system migration, we normally will start from the requirement. The high-level requirement, usually this kind of requirement will come from the leadership. and you won't see a lot of details. You will see a short description of the requirement. Usually I draft it in a user story type. Um, this is a kind of a real example. As a technical leader in finance department, I want a cloud migration for membership inside an analytic reporting system to be lifted and shipped and completed within 90 days. This is the corporate requirement that usually come through the technical team. So if we analyze this requirement, there is some explicit requirement like it needed to be completed within 90 days. It comes with a time. And also it mentioned they want a lift and shift. What the meaning of lift and shift is you actually want all the functionality currently working today. You want it to also work when the migration completed. Other than the explicit requirement, there is actually hidden requirement too. What's hidden? Hidden means it's default. It's nobody talk about that. But if you do not deliver those requirements, some group in the company or your leadership will not be happy. Usually, this include the performance after migrated to cloud need to be better. Or any migration to a new system, they want the performance to be better, and also they want it to be cheaper. Like the budget should be optimized. There is a lower capital expense and operational expense. And also, one important hidden one is you want all the developer, engineer, and user will know how to use them, how to use the new technology by default. And usually nobody talked about that, but that's actually is part of the default requirement. Now, let's talk about the problem and what's really happening during the migration. And there will be a lot of comments. For example, we identify the problem a lot of time by talking with the business and the technical team, see what they think, what they talk. And some common comments we got, I listed several examples. So we will be in cloud and we are going to have unlimited resource. And the design pattern is not important. And inefficient code will still operate in cloud. And people will get really a lot of passion to work on new technology. And it seems like the design pattern become less and less important. Is that true? To a degree, that's true. These statements are true, but their major aspect was missing. One of the things we always talk about is the cost. Nothing is free. And when you have an inefficient code that will run in cloud, but it's not going to be cheap. And also, if you do not pay attention to the code quality, a lot of time, like we have been through the example, some issues was hidden in the system for 6 months, and it's hard to detect. So there is definitely still a high requirement on design pattern. And also there is several comments we got. I must rewrite the whole application to make the cloud migration work, or we have to rewrite modules to be able to use the new feature. And anytime a new function, new feature available, and we have to update our code. All of this is because of lack of design pattern. And also there is a scalability issue and a standardization issue. And I also listed some of there. So we hear this kind of like a complaint from, and when I develop it, it works, but on the sample data. But when I deploy it to the production, it takes a long time and cannot complete. So to resolve those, and one more thing I want to mention is the DevOps CI/CD. Those are relatively new concept. Well, it's not a new concept to the industry, but it's a new concept on data science, data engineering. And the reason is when you move to cloud by default, there will be requirement for you have a quick turnaround. Like you need to respond to change frequently and fast. So all of these comments, if we summarize them, is basically two questions or two comments. It's kind of like a hidden or default because nobody will say that explicitly. They kind of like will imply. This is related to code quality and resource knowledge. So the real question and the comments is, can we have resource with limited cloud knowledge to work on cloud before they are fully trained? So basically the imply is we do not have a team fully understand cloud, but we want to utilize the cloud. How to do that? You do not, as a consulting company or you work with any client, they will not tell you that specifically. Because it's in a way, it's saying the team might not be qualified to work on cloud yet, but we need the project to be working. And the other thing is, can we deploy or migrate program? Well, even though the program is not in very good shape, but could we still be successful? So normally no one will talk about that neither, because basically it's admission or the people who create the system, they kind of like imply their system have some efficiency problem. Nobody will really do it. But if you really think about it, all the challenges probably come from these two aspects. Let's talk about the key to success during migration. Well, actually, it's kind of like for any migration. And after we talked about this, we will talk about it. People will get a laugh of this. We summarize this as a 4 well. So if you want to get a success in a cloud migration, you need to have a very well designed application before the cloud migration. If your application have the right design pattern, the right decoupling, you have implemented like a strategy abstract facade, and it will be much easier for you to do any kind of migration. The second well is you need to have a very well trained team. They know exactly what they were doing, and they know the business and the technology. And you need to have a well-defined roadmap and very well-defined expectation. So basically, people have a clear target and a roadmap together. This is about the leadership direction. And also, you might want to have a cross-functional team collaboration. And this collaboration is very critical, especially when we're working in the cloud environment. The boundary between teams, between like a security network infrastructure team will become very, very light. So the people can do things really fast. And also a lot of time it could cross boundary. And so this is a kind of like a challenging the existing setup of kind of the domain-driven industry, kind of how they organize their workforce team. So if we look at this for a while, normally nobody will really have all of these 4. And the bottom 2 is easier to resolve because normally that's when you can start from 0. If you do not have very well-defined expectation and roadmap, you can do it today. If you do not have a very well organized cross and functional team collaboration, you can do that today. What's going to be really challenging is the very well trained team. It takes time, and very well organized application with a fine-tuned design pattern, that's very challenging. So those are because a lot of time we inherit a system have a lot of patch or have some issues already, but we need to migrate those to the cloud, for example. Because the top two, well, this kind of related, the two hidden questions we talked about is related to the code quality and also related to the developers quality. Now, let's talk about then what's we talked about the requirement usually come with layers from the top level and then to the implementation level, right? And in the implementation level, we could have a detailed problem we want to resolve. For example, we can have from the technical team asking the questions, our team is not familiar with the cloud technology yet, but can we be success? Can we define a platform or can we define a framework that decouple the platform and have the business logic and the platform separate so that we can have it mobile and so that we can remove vendor lock. And also there could be requirement like can we have a framework we can have our not so very well trained cloud team to get training when they are doing the job without significantly impact the their productivity. And also there's a common requirement for any framework. We want a centralized logging, we want a code reusability, we want a configuration driven so that it can have less code get written. And also like we want the resource to be mobile, and that will require standardization. So people working on one project can be easily moved to another project. So based on those technical, well, business and the development requirement, usually there will be, if we finalize the technical requirement for the framework, we can summarize. Those are the, there are 5 towers we want to achieve. We want a framework developed by the corporate or enterprise and the corporate that the system was required to have a configuration-driven setup, centralized logging, efficient decoupling, and it need to be cloud agnostic. Also, I want to deep dive on the streamlined deployment development. So the streamlined deployment, I listed some example about the DevOps. Well, this is a typical kind of integration we were requesting. We asked the version control was managed by GitHub, and then deployment will be managed by Jenkins. And there will be integrated test, security scanning of the code, code quality, code coverage reporting, and build and deploy integrated. And then we have a dependency integration. That's usually something we are going to deep dive today on the like a Kubeflow, Composer, Airflow, and so on. So now I think we're ready to dive into actual use case. It's an example use case we want to address is some framework for Kubeflow. And before we move to the next phase, any questions, issues, concerns?
So I think just one thing, like since you are currently working in enterprise, so like as you mentioned the example, like there was a business requirement to move them to migrate the applications to cloud within 90 days, right? And as a data engineer, what I feel like if you have a strict timeline moving something into cloud, and you do not have a pool of resources who are well efficient in the cloud technologies, as well as they have joined new in my team and they do not have the application on this. So
Yeah.
how do you deal with that problem?
Yeah. That's actually the focus. Thanks, Nishan. So that's actually, let's go through the example. The example is talking about that.
Okay.
And so the actual use case is, well, before we talk about that, right? Let's talk about this again. This is an actual use case happened in a corporate, and we need to address exactly what you just mentioned. So there is a requirement of deploy a Kubeflow. So this page explains why we want a Kubeflow. So Kubeflow is orchestration kind of a tool to help on the machine learning. It's basically a ML version of Airflow. Okay. It's going to resolve several problems. At least that's a requirement. It starts from there's some resource limitation, as we mentioned, right? Like the data scientist, I train my model, use sample data, it works fine. But when I deploy it to production, it's a lack of resource. So is there a tool can help? Kubeflow is one, right? And we will explain how it's going to resolve the problem. And also at the same time, a related issue is when you have a machine learning program, for example, you might have an imbalanced resource allocation. That means that you have thousands lines of code, right? And you do 10 different operations. Only one operation is super expensive. The other 9 consume very limited resource. In that case, you either kind of put gigantic computation power in place, but then most of the time, it's a wasting of that resource. And Kubeflow can do that by separating your code into blocks and allocate computation power, CPU, and memory in different code block, kind of customize that. So you won't waste a lot of computer resource. And also you want to set up the dependency within the program. And also you want to integrate it with the CI/CD. Okay, let's talk about the issue Nishan brought up, right? This is the requirement from the system or the requirement from the leadership. But the problem is, actually I addressed this problem. The team doesn't know Kubeflow. So nobody knows, but we have 90 days to deliver that. How to do it, right? And also there's other well, it's extension of that requirement. At least on the certain item is can we do a training on the job? So can we have my team learning when they do the job without sacrifice of productivity? Right, so there are other items is kind of typical for the requirement for the framework. So what do we do? How to resolve that is we are going to. That's the reason. The main concept idea we have is the corporate need to take ownership to build a framework that is independent of any technology. So in short, what we try to achieve is for the engineer and the developer, they have a limited knowledge, but they could follow steps defined in the framework, and they can make the new system work. And so without fully understand what's running on the back end, they should be able to make the code work. And we are going to demonstrate one of them example today. So, well, this page covered like some high level, like how we did it. This is data processing framework. We'll show something different. We'll show things like the Kubeflow example, but they still, it needed to be centralized logging. It needed to have a configuration driven and also have a library to enforce standardization and a code reusability. Right. So let's see. I will start to kind of share the actual use case. So let's start a bit about it's a this kind of well, so everything about the example we brought up is from our lab environment. There's no corporate related property or data. It's we use ARIS basically one-on-one machine learning application using our example. So the assume I'm a data scientist. I have a program. This is what I listed on my screen. So this program is basically use the size of sepal and petal and to predict what type of flower this is. This is basically a machine learning 101, right? Everybody, all the data scientists have been through this. There's basically no dependency. It's running on any machine, put on my own laptop, right? So if we go through this, this has a data collection, building model, import data, purge them, target data, and then do a prediction, and then do validation. And it's working. Now, I have no idea, no clue what is Kubeflow, but I was required to deliver something like this. So this is basically when we run the code in Kubeflow, you can see it clearly. Well, because this is an example, we do not really need to do this level of separation. Just for demo, we go through each step in Kubeflow. We basically separate, we create a Docker image, and we show the framework configuration, and then we upload the model, we purge the BigQuery data, and upload the sample data, do prediction, and then I aggregate and verify. So how to go from here to here? That's kind of back to the question, right? Usually what it take? One company or corporate, they started to want to utilize Kubeflow. What they do? They will train the data scientist and train the data engineer to understand how Kubeflow works. And then the same group of people, they originally developed they originally developed the program, needed to code. Now they are doing kind of like MLOps work. So is there an easy way or short path? Actually, that's where we talked about it, to use the framework. So we do have a framework can quickly convert from here to here. And we actually put some sample code over there. If we go through this, to generate this diagram, right, we need to orchestrate the dependency. So this part is the KFP kind of module. So in here, we only organize and manage how the dependency was set up between different stage. Like this one is the stage 1, show Docker status. Section 2, show framework configuration, and upload them, create and upload them a model. So this kind of can match to what we define here. And because it's a framework, we do not really have a customized code in the pipeline arrangement. So this could be done even for the engineer without a data science concept, where they might not need to understand what the business behind it. They only need to know what's the dependency. And because it's a standard, right? Like what are those runners? Section 1 runner, section 2 runner, section 3 runner. How they defined is part of the code above. And in this part, everything is also standardized as you run a processing. like section 1, section 2, section 3. Again, where this is section 1, section 2, section 3, that's defined as part of the framework from the package imported from your breakdown on the left. So we'll explain the whole process, right? Like go back to the step 0. I'm a data scientist. This is my program, and I need to make this work in the pipeline. So what I do is I will follow the step, create a bunch of schedule, like a individual independent module. Each module here is the same as my program, but with a wrapper. The wrapper is standardized. You do not need to manage. Data scientists do not need to manage. Usually the MLOP or the data engineer will be. So let's check some code. For example, the prediction phase, right? There's a processor, there's a runner. They have a different functionality. Runner is responsible to set up how to run, how to input the parameter. And the processor is the one actually have the logic. If we go to the processor, you will see the code here is exactly matching to like the prediction here. Like even the function could be a copy paste. So like this is a check accuracy, like you set up the percentage to get the value. Those are matching what we have defined here. So again, there will be some short learning curve for the data scientist to understand where I supposed to integrate my code into the framework. But after the integration, your function will be break down. Well, first of all, you need to break your long program into stage, and each stage will define its own like a CPU or memory. There's a need to that. And then also, if you want to different section of code to be run in parallel, we have an example over there. So after this, you move the code into different processor, and then you have the runner. Well, runner is standardized to invoke the specific processor you create. Now, when all of this ready, the data engineer or MLOP engineer, they will take the output, well, like the module, and draft the dependency. So this way we kind of separate the logic and the technique or the pipeline build separately. So instead of having do we still need the data scientist, the data engineer learn about the Kubeflow? Absolutely. But this gives the opportunity, you can still make something working and make it productive, and without fully understand how the Kubeflow actually work, but you can follow step and make the project work and keep moving forward.
So basically, like you are following the basics of any fundamental computer science program, going to the OOPS concept and solid principles, and making your program as modular as possible, so that individual component like established, and like data scientist will go to the particular component he need to focus on, data engineer will focus to the component he need to focus on, similarly for MLOps.
Correct. That's kind of like basically the concept. Well, the reason we are doing that, we'll I'm not sure how much time we still have, but we can go to the detail like how we set this up, and we want this to be kind of the vendor agnostic. Actually, the same version of the code have been there's a different version operating on the Dataproc or the Spark system. And it's the reason how it works. We decouple the bottom line, the system itself, and the business logic, because your business logic is in these processors. And there is some inheritance design pattern here, since every processor is actually go as a child of the AI processor. And all the logging, all the functionality, all the kind of governance and the strategy of your operation will be defined over there. So you inherit from the AI processor, and then you will inherit all the functions and the rules required. For example, after you copy like a code or integrate your code, then you can have the tracker functionality in place. And the tracker, the job tracker, is really a logging process. And how to integrate with GCP or Databricks or Dataproc, different technology, it won't impact your interface. So when you want to track like the message, like I want to mark this step as completed, I want this into the logging, you only talk with the tracker that you got from your parent. You do not need the business developer. Well, we say like the data scientist. You do not need to care how the tracker integrate with GCP. So that's how when we move application very well patterned in Azure to GCP or from GCP to Azure, it doesn't take developer to recode the whole thing. You only need to recode the connection you have in the parent. And one of the tracker I can show this group is so for example, well, the program we just talked about is called the let me see, is the Aries one, right? So something happened. Yeah, this is the Aries project that we executed. And if you can see, the stage have a step 1, 2, 3 is organized, and on each step we also have the event. Like on the stage 1, we have 1, 2, 3. We have init, refresh configuration, and functionality. And those could be put organized in your database. And this could be also sync to the GCP environment. It could be plug and play to any platform. And also this become extremely useful if you want to permanently save some result. For example, one of the projects we were working on is we want to find out the performance of different solvers. And the solver, commercial solver, could have different license. It could be a floating license, it could be server-based license. But it's the same algorithm, but running in different environment. We want to know the performance. We can capture those performance here in this like the permanent logging. I probably have yeah. So like this is the result we captured for the solver algorithm, and we actually captured the time, critical time. We want to permanently save it here, and we can capture those in the logging. And we do not need the data scientist or the actual developer to be fully understand how the backend work, but they can utilize the function as far as they know the signature.
How do you handle the dependencies like scikit-learn or XGBoost?
Yeah, very good question. Thanks, Luke. So in here we do, well, that's also part of the framework. So there is again, when we talked about them, first of all, the main idea of this presentation is the importance of design pattern. We're not even suggesting this pattern to be the most effective. It has a way to handle dependency. Again, there will be a lot of improvement required, and actually continuous improvement, because we have migrated the framework many times already. So the whole process is started from 1, 2, 3, and 1, 2, 3, 4. The 3 is missing because the 3 is based on here. when we this step is to actually build the Docker image. We have a code algorithm over there, and you can see there's a Docker file specified. So this file will be kind of like basically put all the dependency, like you mentioned the scikit-learn is here, right? Scikit-learn and also NumPy and also like the Google related library. That's scheduled here. So when you build the Docker image, you actually take this Docker file and put it in the Docker. And there is also a step to copy your code into the Docker image. Like this is a kind of like this step. Again, we follow specific step defined by the framework to build a Docker. And does that answer your question? Yeah. So and then this is again we are going to show another example because Iris is a one-on-one, right? Like the one kind of like 101 machine learning. So what if there is a complicated situation? We do want to talk some of those. Like for example, let's pick up one for the Cplex. So again, the Cplex is if we bring up okay, this is the Cplex one. So for example, the Cplex is what do we do? We will walk through. Well, what we want is we want to find out how efficient the Cplex is running as a Docker version or as a server version. So the difference is the Docker version is you create a Docker, you have the algorithm processor embedded in the Docker image. And that's going to be costly because every time you create a new Docker, you will kind of need to pay for the license. Or you can have one server defined. And this one server defined, and you can have a multi-thread connected to the server. So it's less costly, but the efficient is really bad. Well, is that really, really, really bad? So what do we want to find out? So we want to kind of have a multi-thread on Docker and then multi-thread on server. And then from there, we can compare what's really happened. If it proves when we run multi-thread for 4 or 5, that's all we need. Then the server version could provide what we need. Why we want to pay more expensive kind of Docker license. So if we go back to the code, so the algorithm we were trying to run is this is the sample program we actually got from the community version example. So the good thing is usually all the example provided by the vendor, they are very well staged and kind of in really good shape. It's easy to break them out, right? So what we were trying to do is we take this code. Well, this code is defined to be able to run on any environment. We take this code and then we go to our framework and we build a Docker runner and Cplex runner. So in the Docker runner, well, I will just show the example. This is kind of like almost a straight copy here. So this is exactly match what we have here. The only difference is we put it into a function so that it's callable. Then when we build the pipeline, since all the logic was embedded into each stage, so our pipeline is only care about, well, this is the place we build those runners. Again, it's just invoke. There's no logic. It's just the definition, declare the process. And then we can set up the connection, like the dependency between each job. Since we want to have like 3 Docker image run and 3 server kind of run, and in between we want to pause the execution, right? So this is kind of like how to handle, and we can show an example. So right now we have like a 3 server and 3 Docker image running. So assume if we want to have, I will enable this code and disable this code. So what we want is we want to have one more Docker kind of like running in parallel, and we want to see what's the impact to our performance. Basically, instead of we have 3, we want to have 4. We can just add one more runner using the same runner as we run in parallel. And we can actually access this code and see, usually this will take like 2 minutes to complete.
How does the developer take advantage of a pre-built component?
Oh, very good question. Let me fire this up, and then we talk about that. Okay, so the pre-built component is actually built into the library. So the structure on the left, we have config. This is a system level of configuration. So when you move from a dev to prod, or when you move from even one system to another system, this is the place you try to make the configuration. And this configuration will impact everything, all the program. And there's a library. So this is the library. The library is the common used utility. We build all the utilities here, like the key store, helper, and AI util, GCS util, and that's where we define. And also the root class for the analyzer is built here too. So that's the AI util. And then in the works, this is where your project will define. Like every one of like the areas is a program, like the Cplex, Groovy, all of those are the project. So each project will share the common library and will share the config. So if I want to use, like for example, if in the Cplex, bring that. This is the areas. Let's build the find the Cplex. If the Cplex I want to use the predefined function, the function actually defined in your parent, and you can invoke, like the tracker is a feature we developed in the AI processor, because you are inherit from the AI processor. You can utilize the function directly.
Right. What about like, so one of the ideas in Kubeflow is that if a key machine learning step has to take place, like sentiment analysis, which is intensive, is often coded in Java. Mm-hmm. You could in Python invoke a sentiment analysis component. Mm-hmm. And get all the benefit of that analysis mm-hmm. in the same pipeline. Mm-hmm. Because that's a pre-built component that's just, you can reference it by URL, and the component defines inputs and outputs and runs.
Let me show an example actually. So we have, let me close most of the window here, so that we can get a clear screen to talk about one of the example. The example, like Groovy, we were doing some tests with Groovy. That's another solver. There's it has a version you needed to have a server defined. So how the code work? If we go to the single program, is again the single program is your original program, and if we go to the sample code, what do we have here? It's required we build a token server that's actually in our intranet. So this works because this is running on a VM in the same internet. So you can connect it to like the algorithm provider. So basically what we do is when we start, we send data to this server and then get feedback from that server to resolve. So, but this will become challenging since when we deploy to Kubeflow, Kubeflow will generate Docker. You want the Docker to be able to connect to the server, right? The algorithm provider. So that's why this a framework was actually created on AI platform, not on Vertex AI. And because AI platform, you have control of your environment.
But like what I'm saying is there's no artifacts.
No artifacts, you mean, if it's a library as artifacts, you mean, you need to have that artifacts in your dependency on the Docker.
No, so like there's functionality in Kubeflow for it to essentially provide a data file. So like what I can define is I can take a Java program to say extract data from a PDF.
Mm-hmm.
So the first task can get all the PDFs together,
yep,
and base64 encode them.
Okay.
That's a task.
Okay.
And I could write that task in Python or whatever.
Okay, yeah.
But the next task is actually receiving a data file
mm-hmm.
that is every base64 encoding
mm-hmm.
and using Java to extract the text from every PDF.
Okay.
Then I have a new data set that is text that now I can send to the next task that is a Python sentiment analyzer.
Okay, yeah.
Right. And like one of the keys is that a data engineer could create the base64 extractor
mm-hmm.
as a Kubeflow component, and it receives this input and it puts this output out.
Yeah.
And that now no longer needs to be touched, and any data scientist can pick it up and just call it as a component by URL, mm-hmm. right? Because they're defined in JSON. Do you follow?
Yeah, I follow. I follow. Yeah. Do you have any comments? Okay. So is that similar to what we discussed about the arrays example? So in this example, well, it's kind of like you want to persist either your data or persist the model in the training process, right? So like in this pipeline, we have, for example, when you permanently purge the BigQuery to clean up your targeting environment, this is outside the Docker, outside Kubeflow. And also when you create the arrays model and upload them, you actually create a Pico file and upload it to a GCS bucket. That's external. And so those could be achievable as far as you have control about where you run the Docker and you have a permission to access those resources.
Right.
And similarly, like the code we mentioned on here is we not really, well, the Docker image is dynamic created, but the server like the URL like going to respond to your algorithm request is static. So this could be resolved by you have your Kubeflow running, like your pod, your service running inside the same VPC.
Yeah, yeah. I would. That's my one concern is they've created a method to pass data through the components without ever knowing or having to even inherit the location of the data.
Well, we didn't resolve that internally to the Kubeflow.
Yeah.
We didn't do that. We used the kind of like the external storage to achieve that.
Well, so it is external storage, but it's passing the references along, right? So like that's one of the that's what I'm worried that
I'm getting from your point, you're trying to just take one artifact which takes one input and gives the output. You don't have to worry what's happening in middle such things, right?
Mm-hmm.
And then whatever artifacts you're publishing, creating, it might be executable file or bad file, whatever. I'm just giving an example. Yeah. And then you can publish on the Docker.
Yeah, well, I think that's I'm thinking if I have an example for that already, but the concept is I feel like you have a staging table or a control table or control external storage. You can read and write the status. So that's kind of similar to the external the usage of the external storage.
So it is using it externally, right? What's being passed from component to component is actually just a JSON reference.
Yeah.
That is the path to each thing.
Mm-hmm.
So, and the reason that's an advantage is you never have to know when you're coding the component, you don't need to know the name of the staging table because it's supplied through injection.
Yep. Yep,
right.
yep.
So,
well, let's that's something interesting, and we will kind of we didn't cover that part yet, but it's definitely a good topic to kind of cover, and we need to get a better understanding of that. As I mentioned, right, it's there's always a new technology. It's evolving really fast. So, but the major idea we have is. It's more not on the as a technical provider side, technology provider side. We are the user side, so we do not want to have vendor lock.
Yeah.
So because today one vendor is better than the rest of them, they are the top one, right? But we do not know if after 2 years they're still the top one. We want to always get the best. Breed, right?
Yeah.
But if you got a vendor lock, and then you basically lock down. It's too costly to move to another environment. So my point is, our point is, we want to have a very well-defined design pattern to decouple the technology you are using and your code and business logic. Do we have still have time where we kind of can? How many time we still have? I lost track of the.
I think one say that we give the presentation.
Okay, so we kind of skip the lunch time.
Just catch up the lunch. But you can ask where is the seat?
Yeah, it's on the other room.
Okay.
Yep. So any other questions or any other topic we want to cover? I will stop sharing. Let's see. Yeah, well, there's some technical issues at the beginning, so we kind of delayed the whole process.
Yeah, no, yeah,